OEMs and manufacturers should require component digital twins from suppliers. One challenge to implementing a fully model-based enterprise and achieving Industry 4.0 is the lack of quality supplier data, especially supplier CAD data. To understand why supplier CAD data is of such poor quality, you first must understand how engineers are getting supplier data. Engineers typically access supplier data in one of three ways: through a physical or digital supplier spec sheet, requesting a CAD model from a supplier, or downloading a neutral CAD file from the internet. These methods present several issues, both with the lack of efficiency for engineers and with the low data quality provided. Spec sheets. When using a supplier spec sheet, that's the information that's typically provided in absence of a CAD model, a design engineer must create a CAD model representing the supplier's data. The first issue with this method is the margin for human error when translating the information from a spec sheet to a 3D CAD model. Engineers typically only embed the metadata they need for their specific job. Data required for downstream processes often won't make it into the model. Having engineers create 3D models from parts that already exist is a colossal waste of time. Engineers admit to spending 25% of their time searching for and recreating supplier parts. That's a lot of time. A lot of wasted time. Requesting CAD. If a part is complicated or requires customization, engineers will request a CAD model from the supplier. Typically takes 3 to 14 days for the engineer to receive the CAD model. The model is typically a neutral CAD file format, which doesn't have essential metadata required for Industry 4.0 initiatives, or design intent as we discussed earlier. Downloading a neutral CAD file format from the internet. The final way an engineer gains access to supplier data is by downloading a CAD model from the supplier's website or third-party site. Unfortunately, CAD from supplier websites is often delivered in a neutral CAD format, lacking quality data, or only offered in one native CAD format. All these options slow down the engineering process, weaken component manufacturers' ability to sell parts, and are full of low-quality CAD data. That's where component digital twins come into play. So what are component digital twins? Component digital twins are high-fidelity native CAD models that are equipped for Industry 4.0. Native CAD formats are the power behind component digital twins. Native CAD formats preserve design intent and contain critical data. Supplier component digital twins. Typically, component manufacturers provide a neutral CAD file for engineers to spec into their designs. That worked great in the past when engineers needed less metadata embedded into the CAD model. Today's engineers need component digital twins. To meet crucial Industry 4.0 requirements, component manufacturers must provide CAD models in a native CAD format. By offering native CAD formats to engineers, the manufacturer's CAD files match any CAD software their customers use, preserving vital metadata and design intent. Native CAD files can store data necessary for departments downstream from engineering when compared to neutral CAD file formats. You can learn about the differences between native CAD formats and neutral CAD formats in the ebook linked in this sentence. Metadata for Industry 4.0. CAD metadata is data embedded within a CAD model that provides supporting information, increasing data fidelity. Here are a few examples of CAD metadata for enabling Industry 4.0 functionality. End-of-life information, obsolescence, IIoT tags, materials, finish, tolerances, battery capacity and longevity, wattage, speeds, horsepower, and max RPMs, full range of motion data, and unique manufacturer part number. The metadata needed varies by component type. When making cost projections for a project, it's critical to factor in the cost of collecting and embedding this metadata if your suppliers don't provide it. When engineers must manually collect and embed the required CAD data for Industry 4.0, supplier parts add high costs throughout the product lifecycle. Having to collect this information causes bottlenecks and breaks the digital thread. When suppliers provide Industry 4.0 enabled component digital twins, They save engineers much time and ensure data quality for their customers. In some cases, having high-fidelity metadata certified by the manufacturer is worth more than the component itself, considering the cost of finding and adding the metadata after the fact. Why component digital twins are good for manufacturers. Component digital twins give manufacturers a competitive advantage now and future-proof their CAD catalog investment as more companies require Industry 4.0 metadata from suppliers. The second reason is that component digital twins are more likely to be purchased by procurement professionals and digital procurement software. Purchasing friction is reduced because component digital twins include the unique manufacturer part number within the CAD model. When engineers spec components into a design, a company's sourcing team must purchase the part before it goes into production. If the manufacturer's part number is embedded in the CAD model's metadata, the part number can be transferred directly to the BOM, or bill of materials. If a manufacturer's part number is on the BOM, it makes it incredibly easy, in fact, easy as pie, for procurement to purchase that exact part. On the other hand, if they have to search for a part number, they may end up looking up competitor parts and purchasing them instead. Component digital twins also enable automated procurement software to purchase the manufacturer's part, increasing sales for the manufacturer. Industry 4.0 for procurement necessitates that suppliers provide component digital twins so that the metadata is available to use automation programs to purchase parts for the initial production and automatic delivery of parts for maintenance in the future. Is your data ready for Industry 4.0? The new industrial revolution is underway. The factories of the future will be functioning with few humans on the factory floor. Productivity and safety will improve, and the market will get better, more customized products in less time at a lower cost. Is your company ready for Industry 4.0? Have you considered how your current strategy can be disrupted by factory automation and the market's demands? For the component manufacturers out there, has your team considered how the demand of Industry 4.0 enabled CAD models and component digital twins will affect your business? Do you currently have a strategy for delivering the CAD data your customers will require in the future? These are central questions to think through for businesses looking to survive the new industrial revolution. Forward-thinking companies have already begun their digital transformation and are prepped for a significant competitive advantage as the missing pieces of Industry 4.0 come together.